there's a lot of abstract steps when we talk. Well, this somehow triggers this, that somehow triggers this, that somehow does that. And then my job was to find a real life way of making all these somehows actually work, because the machine had to work, right?
Adrian is so right. Now that we had a plan for the machine on paper, we needed to get the machine living and working in the real physical world. It's time for the build.
The whole physics of a Rube Goldberg machine is based on potential energy. So everything that's ready, every step is a more complicated version of the dominoes, right? So a domino that's standing tall has a lot of potential energy because a little push will create more energy once it's toppled. So a bucket of liquid that's just about to be spilled is potential energy. It's at a certain height, and then we use gravity for just about everything to push things over.
One of the top questions we've been asked about the project is, so how long does it take to build?
I know for these things that I always underestimate how much work it is, and I try to build that in, and even accounting for my regular underestimation, it was even more work.
The answer to this question would obviously vary depending on the type, size, and complexity of the Rube Goldberg machine that you're building. For our project, the build took a total of 3 weeks and can roughly be broken down into 3 sections: the foundation, the moving elements, and the set design.
The dimension of the machine was it was a cube 4 foot by 4 foot by 6 foot wide, going up to 9 foot for the crane that held the globe.
Even though our machine was small by Rube Goldberg standards, the structure still had some significant heft.
I started by building a structure, so just the box. It had to be reinforced at the back because I knew I had a rough idea of the physical load that would be put on it. And so a normal set that just would have to be decorated could be assembled pretty fast, but this one had to be engineered not to collapse on itself or to tip over, and also to not vibrate, because a lot of moving pieces, like we didn't want one part of the Rube Goldberg machine to shake the whole thing and trigger another part that's kind of loaded and ready to go.
Because our machine would be telling the story of single-use paper and plastic products, it was a no-brainer that the machine needed to be built by reusing existing paper and plastic materials.
For the actual building, the fact that it was that canopy focused on recycled materials, I love, because that's how I usually build anything. I try to reuse as much material as possible. If this had to be the finished product to look a certain way, the machine we built would have probably been the prototype, and then we'd have to recreate every parts. But I'm really into just making do with what we have, kind of that famous scene in Apollo 13, like here's a bunch of crap, let's make something out of it, right? Like I kind of like that.
Once the foundation was complete, Adrian built the machine section by section. As he worked to get each individual piece of the chain reaction working, I was building the tiny models that provided the machine with context and storyline, including a woodland scene to be drenched by an oil spill, a cardboard city made out of old makeup boxes, a toilet paper forest at the base of the machine to be clear-cut by a toy bulldozer, and an ocean model for our floating plastic island. As we worked, we definitely came upon some unexpected challenges that required patience and problem-solving. For example, the marble run.
Materials that are not as fluid as water, let's say like marbles, also have aspects like friction. They'll get stuck together in a funnel, so we had to plan this. This one was a particular spot that took a few days just for that one scene.
Another practical challenge was that the machine had to be easy to set and reset.
That was the other part too in the concept thing that I had to keep in mind, is I knew we'd have to reset it, and so many steps. In the original drawings, we had things where like a bunch of things get destroyed. And I just knew that would be, if you imagine a Lego piece has to explode in many pieces, every time you reset, you have to rebuild it. So I had to make it in a way that wouldn't take too long to reload. The toughest part would take us maybe 5 minutes, and that's the compounds, like that adds up.
It sure does. For example, there's a portion of the machine where we had water dumping into different containers in the chain reaction, and every time we ran the machine, we had to reset the water, as well as the trees, the trucks, both marble runs, the globe, and the garbage. My job was also to bring my design eye to the machine as a whole, to visually unite and clarify the story. This involved adding labels to the various parts of the machine and drawing 2 4-by-6-foot murals on the wooden panels which depicted the factories and landscapes destroyed by the paper and plastic processes. On the paper side, the machine starts with a tropical forest, heading through a more North American landscape down to the mill, with the base of the mural depicting a paper mill factory. The plastic side starts with a mountain landscape with an oil pipe cutting through it, heading down into a plastic processing plant, surrounded by a tropical landscape, giving a sense of the lakes, rivers, and groundwater that are polluted through microplastics and factory chemicals. When I say the build was time-consuming, I'm not joking. The mural alone took me 18 hours to draw and ink. We successfully took this project from concept to real life, and it's looking so cool. Now that the machine is built and mostly working, it's time to get the cameras. In the 5th episode of this series, I get into the filming process for our Rube Goldberg machine. See you there!